Okay, now we're going to have a brief discussion on edge and vertex partition or decomposition in connection with this graph, the even graph. Because Aurelian graph is basically the even graph, but even graph put together, so it's connected. Now we will see what we can say when the graph is even. It turns out that whenever graph is even, actually the building block of even graphs are cycles. The cycles will be basic building blocks of even graphs, in the sense that whenever we have a non-empty even graph, so whenever graph contains at least one edge, so that's what we mean by non-empty. And we can always partition its edges into cycles. Then if we look the another way around is we use cycles to build up an even graph. So take a look at this example. We can decompose edges of this graph into 3 cycles. There are 2 different ways. One is this one. Another 5 cycle. This one. That's one way. Another way is 4 cycle inside and 6 cycle here and 3 cycles here. So it's an edge partition. But these 3 cycles share no edges, but they may share vertices. So this one actually means every even graph can be obtained by edge disjoint union of cycles. So therefore, cycles are really building block, basic building block for even graphs. Because we just put cycles together in edge disjoint way to form even graphs. Okay? So that's about edge decomposition. Now, in connection with vertex partition, what we have is we can always partition a graph that is not even graph into 2 even graphs as induced subgraphs. So whenever G is not an even graph, whenever it contains at least one order degree vertex, what we can do is so we can partition V into 2 parts, V prime and V remaining parts, such that none of them are empty. They're not empty. None of them are empty. This one not empty. This one also not empty. Of course, they cannot be empty, right? Because one empty and one graph is not even. Then both sets, V prime and the V minus V prime, both of them induce a subgraph. That is an even graph. So inside this graph, every vertex has even degree. And inside this graph, every vertex has even degree. Okay. So what happens is like this. Right, so vertex set can be parted into two parts. And here, these vertices will induce an even graph. For example, every vertex has even degree. There are special case, even degree can have degree 0. Isolated vertices are allowed. So here maybe a B prime together maybe with a triangle. So it may not be connected. So inside this part, there are no other edges. Look like this. Inside there are no other edges. Look like this. Even graph, even graph. All the other edges will be cross edges. So we may have a connection like this. All right. Suppose this part and this part induce an even subgraph. Now this one is important when G is not even graph. If G itself is even graph, we may not have such a partition. For example, all the cycle. All the cycle, we cannot partition into two parts. And none of them are empty. If empty, of course, one part is empty, one part is this part, this tribute. Only one partition that none of them are empty. Of this one cannot. There are no way to partition that because the number of vertices here is odd. We cannot do it. But if it's even cycle, then it's possible. Even cycle. No, now even graph means degree even, but not necessary to be a cycle because there are special case of isolated vertices. Vertex degree can be 0. So this one looks like impossible because it's only one cycle, but after partition look like this. It's isolated vertices. So here is V prime. Here is V prime. Here V minus V prime. So inside degree 0, degree 0, degree 0, degree 0. So it's possible. But for pi, it's impossible because it alternates. Because length 5. So if we put 2 here, then I have to put 3 on the other side. Then we'll see that there will be an edge in one of the parts. So it's impossible to partition that into, say, isolated vertices here and isolated vertices here. So that's why we need graph to contain at least a vertex of order degree in order to have non-empty partition. So it's very important. Non-empty, non-empty. In order to get non-empty one, then we have to contain at least one order degree vertex. Of course, that means at least 2 order degree vertices. So that's vertex partition result in connection with even graphs. And then this result, we'll use it to discuss our third application, light out gain. So we're going to use this result to see how we can construct a solution for light out gain. Okay, all right.